Welcome to Guide Guru. We hope this video helps.
You begin by identifying the two refractive indices and preparing the interface so measurements are accurate. First, confirm N1 is greater than N2. Total internal reflection only occurs then. Next, align a ray source and a protractor so you can measure the incident angle from the normal precisely. Once done, take a small angle and increase it stepwise, recording each incident angle and observing the transmitted beam. Make sure to note units and instrument 0 errors before proceeding to calculation. You now apply Snell's law and set the refracted angle to 90 degrees to derive the critical angle. Explicitly, rearrange n sin theta c equals n sin 90 degrees, which simplifies to theta c equals arcsin, n/n1. Because arcsin requires an argument between -1 and 1, make sure n/n1 less or equal to 1. If not, there is no critical angle. Then compute theta c using a calculator in degree mode, double-checking your n values. Once computed, compare this with measured angles to confirm consistency. You finish by verifying the calculated critical angle experimentally. Slowly increase the incident angle until the transmitted beam disappears and internal reflection begins. That observed angle should match theta c. If values disagree, inspect your measured refractive indices, realign the setup, and ensure the protractor reads from the normal. Also consider beam divergence and surface imperfections, which shift the apparent transition. If problems persist, redo index measurements with known samples and repeat the comparison to isolate systematic errors.
Thanks for watching. Consider subscribing if we helped you today.